debugger configuration is done. So let's write the selection sort algorithm. So basically, in a given array, we assume the very first element is smallest, and then for the rest, find if there's any smaller one, then swap it. So we have loop, first element, to the last, we are going to do loop as follows. So assume min index is I, the very first one, and then for the rest, so int k, so I plus 1. So except the very first one, and then to the last element, just find if any smaller one, so min index. So if data at k is smaller than data at min index, then meaning of that is this is a new index for minimum value. So k is there. So we keep working on that. For the rest, just keep working on that, and then we will update the actual minimum index. Then so found min value at min index is there. Then swap from the array called the data, the value at index I and at index min index. Then we just keep doing so, then selection sort is done. So we need a function that enables swapping in given array, and then two positions I and k, two positions are given, then swap that. So this is a prototype, so we don't have to give the parameter name. So that's a prototype. Now let's implement the actual swap function. Int array, int ith position and kth position data should be swapped. Swapping means we get a temporary value at, index I, which is array. Then I value is updated by k. Then at array index k, the stored value is there. So this is a swap function. So this algorithm is based on the animation video you watched in the previous video. So assuming the first one is the smallest, then for the rest find any smaller one and then swap and keep doing so for the rest. So let's test this program quickly. So here the selection sort is defined in other files, so we need to declare prototype for reference. Selection sort array, and the size is provided. Then let's create the data. So const int n is the number of data. Let's begin with the small ones. Then let's generate random data randomly. To enable random data generation, we need to have a ctime library, which has time. So using namespace std, we may use iostream for cout as well. So let's include those ones. So for random generation, we need to do srender time null ptr. And we initialize the seed of the random number generation by the system time. Then let's define data set with n elements. Then I is 0, I is less than n, I plus plus. Then in data I, let's assign random function call, and then we don't have to limit though, but let's limit the range. So let's define constant range is something like that. It's no bigger than 100,000. So you can adjust that as you like, but it's not important. So that's the random number generation, and then it is initialized in this array. So now we can call selection sort algorithm. So selection sort given data and size is n. Then let's see if it's really sorted. Plus plus cout data I just blank int I is 0 and the like. So we line semicolon. So we have everything done. Now create make file. So a.out is the goal and the main.o is needed. The selection sort.o is needed. Put together there. And selection sort.o is by compiling selection sort.cpp, which does not include any other file. Minus C compile only is there. And main.o is by compiling main.cpp. Minus C minus G main.cpp is there. So main.cpp does not include other things like selection sort. Now let's compile and let's run. Then here is the data. You can verify visually whether there is ascending order or not. It looks like it is all ascending order. So we may write a program to verify the data though, but I just briefly visually verified if a selection sort algorithm I implemented here is working or not. Later we are going to design some comprehensive testing code though.